Okay. Good morning, everyone. My name is Kyle Escamilla, and I am the training coordinator for AVEVA Select California. I'd like to thank you for attending our Learn in 30 webinar today, focused on AVEVA Unified Engineering. After the webinar this morning, we'll be doing a short Q&A, so please type any questions or comments into the Q&A box, the chat box, or you can email us at webinar@california.avevaselect.com. Now, I'd like to introduce your presenter for today's webinar, Sam Karuf. Sam is a senior design and application consultant at AVEVA. Good morning, Sam.
Good morning, Kyle. And thank you very much for the intro. And I'll be going ahead and sharing my desktop and ready to start. Let me do that right now.
Perfect, perfect.
I presume you see my desktop as this minute.
Yep.
And I'm going to go ahead and share my slide deck with you as well. It's taking a little bit time. What is going on here?
Maybe try quickly restarting the share if it's... Oh, I still see everything.
All right, let me bring it here and... Yes, here we go. Okay, perfect. Hopefully this doesn't happen to us again during the presentation. If so, and I dropped out, I'll just, because we're having a little technical issue this morning, I'll just resume again. So please be patient with us as well. Okay, let's get started. We only have 30 minutes. Thanks for joining us today, whoever you are, wherever you are. And thanks for taking really the time of your busy schedule to attend this informative session regarding unified engineering from AVEVA on Connect. And I hope you learn something from us today. And please, as Kyle, my colleague, mentioned, put your question or leave them till the end in the chat, and we will be more than happy to answer them, assuming that time will be left over for our today's session. Okay, the topic today is basically AVEVA Unified Engineering on Connect. It's a data-centric engineering and design execution approach. That's really the title. Let's talk about now the details of it. What is Connect and what is unified engineering, as I mentioned in my previous slide? Connect is really the intelligent platform for the connected industrial ecosystem or economy. It is an open and neutral, providing rich data insight for unified industrial ecosystem. That's really the platform that we use, which is a cloud environment. Unified engineering is really a set of applications and analytic. It is the foundations for capital project excellence, and it also really accelerates new value creation for our customers. Those are the two acronyms that you use and you will hear from me, but as describing them, keep them in the back of your mind so you can understand the difference between both of them. Moving along, we at AVEVA really fundamentally offer a software that helps really the ecosystem and to make businesses, infrastructure, managers, on-site operator more sustainable. How so? By delivering a really complete digital thread solution that encompass the life cycle of the industrial plant, from the design to operate to optimize. This system is really open and agnostic. And it is basically two pieces of it, the engineering piece and the operational piece. On the left-hand side of the screen, it is the engineering piece where data are collected, aggregated, and stored and contextualized. And the same thing as the operational piece, which is more of the real-time data that is collected, aggregated, and also contextualized event and self-service calculation built into it. Now, as you can see, the portfolio solution that AVEVA offers is basically runs across the digital twin, but today we will be talking about really one subset of that, which is the engineering and the execution part of it, which is the unified engineering. And that's our focus for today. Moving along, just to give you a perspective of the industry and the market pressure that we see and foresee in the future, which are really 4 segments that I will talk about. And those are done from really reliable sources as to the survey, like for improved team performance. 90% of really the surveyed business leader believe that using technology to improve outcome and team performance is very important to them. And that's according to the Deloitte. If I were to click on that information, it will bring me to a slide, that website for this survey. And in the survey, it talks about really that particular numbers that I have showed you here, which is more than 90% of the business surveyed, believe in that improved team performance. Just moving along here, at the same time, data management, really technical industry leader, see really the major barrier in, and 45% of them in managing and managing the data that they have gathered during the project execution. Moreover, many of the EPC's firm, or over than 77% of them, they like to really invest in technology in order to improve their performance. And finally, organization really believe that they are wasted $15 million every time they execute a project because of because of a poor data quality. That's just the numbers according to surveys that was done by those sources that I have mentioned in below screen here. Now, based on that, what is the required capabilities for a system like a data-centric approach is required from these people that was surveyed? The required capabilities from the simulation point of view, which is part of the unified engineering solution, they wanted like a 50% faster feed stage in order to accomplish that. On the collaboration side, they want to track every change management that happens between project disciplines. If it changes happen on the process side, I needed to alert my electrical or my instrumentation team of those changes and also track them. And also connect those disciplines in some sort of notification to be automatically triggered among themselves. And we will see that in some of the videos that I'll be showing today as well. This will reduce also, if we have that capabilities, it can reduce really the project the project schedule by 20%. Finally, which is most important and the talk of the day, is sustainability. Meaning if we use a system like that, we can reuse the data that was gathered and the standard along with it and make the digital workflow automatic. And that really could save us 5% of the TIC, the total cost saving in the design phase alone. And finally, on the engineering and the design side, we end up with an integrated system and an intelligent document that is getting generated, and that could increase the efficiency in the engineering by 50%. Moving along, AVEVA really unified engineering on Connect, as the title says, is 2 hubs, which is the simulation lifecycle and the integrated engineering design, which really covers the conceptual design, the front-end engineering design, and the detailed design. And that's what we refer to it as the unified engineering. And we will talk about it in details in the next few slides. This really also unified engineering also used for streamlined project execution. When it comes into the project execution, all of these are set for the project execution in terms of commissioning, handover data, and all of these things are in place. Moving along, this slide gives you a perspective of what is people are complaining about compared to what would they like to see themselves while executing projects. And we refer to them in the industry as defining the EPC 4.0, which is our current status, compared to the EPC 3.0 that was accustomed to EPCs to implement on the project. In the EPC 3.0, we always dealt with we had the project teams over the past 2 decades, different systems and standard. Most of the data was gathered in silos, meaning in Excel spreadsheet, in just a flat plane document. And it was really difficult to pass on information between the disciplines. So they left in a nightmare. What is the latest data? Which Excel spreadsheet has the latest information on the mechanical data or the process data? Now, comparing it with the EPC 4.0, which is a basically shared data environment and data-centric, one single source of truth, eliminate all of the problems that we have with EPC 4.3. With this model, we move to really a data-centric approach where data is the center of the integrated solution. The team member, the project people who are executing the design phase of the project on the industrial plant work and share the data from one single source of truth, where where we allow team member either to consume the data or even author the data, depending on the accessibility to the system. If I'm a process engineer, I can basically author data, process data to be used by the instrumentation engineer. Instrumentation engineer or electrical engineer can consume data and author more data pertaining the electrical specification on his design for the project. That's just to give you a comparison between where we were and where we are now with the data sharing and the data-centric approach. And that's, we refer to it in the industry, the EPC 4.0. Moving along here, what I wanted to talk to you about is enabling that and through a cloud environment really allows multiple discipline team to collaborate across the design phase, where we refer to it as the 1D, which is the data, the 2D, which is the schematics, deliverables on a project, or the modeling and the visualization, which is the 3D from a data-centric location and one single source of truth. What does it accomplish? It basically accelerates team to project time to project startup across all disciplines. It communicate and collaborate effectively across all disciplines as well. It is basically sharing information seamlessly and quickly find the access to the right and the latest data as well, and also view and validate changes among the discipline themselves in real time. If a person changes it is notified with some notification through the process to the other discipline team that those changes happen and action should be taken by the other discipline engineers. And we'll see that live. Now, back to the unified engineering, there are a set of tools, as I mentioned earlier. Starts from the conceptual design and our process simulation application, and then into the engineering, the tag registry application, also the instrument and the electrical application, along with the PNID and the 3D. That really basically consists of the unified engineering solution. Those comes in the cloud. you can basically subscribe as a SaaS and a LaaS. What I mean by SaaS is the software as a service. LaaS is a license as a service, meaning that you can buy a bundle of licenses, and that is the business model of it. We have the flexible business model, and this license can be shared among, as a subscription among all the application, which makes it easier to keep really the software you are using are up to date, and easy access to consuming license and or consuming what we refer to them, the business model, the flex model, the tokens that you will be utilizing for the application. Now, the workflow as well. The system, since it is open and agnostic, it is open to tailor it towards your workflow of executing project. So the workflow between the application, let it be process flow diagrams, let it be process and instrumentation diagrams, or electrical and instrumentation, or a process simulation, or all working against one central database. And this workflow can be set and tailored towards your needs as you are executing projects. Now, I wanted to, because of the lack of time, I want to show really what I have described, the best 6-7 slide in a video that I captured of how data flow and how information gets passed on, and the collaboration between the data during execution of the project among the design discipline team. Let me go ahead and I'll narrate what is happening in that video, and I'll try to stop it at any point in time and move it as we go along. I'm gonna go ahead and start it. I'll put this. Can you hear the audio or no?
I don't hear any audio.
Okay, so I'm gonna stop the audio and narrate it myself here. What's happening here? A process engineer using our process simulation application and building a hydrogen plan is going ahead and doing the design work. And after he's done, he wants to basically go ahead and take a snapshot of what he has done and pass the information to the other discipline engineers by going and defining the case scenario that he is doing for this hydrogen plan, whether it is running in the winter or whether it is running in the summer. And that's what he's doing right now here. He's creating two cases with different data sets. One case, temperature changes between the summer, and now he's capturing the winter case or the summer case and publishing it by taking a snapshot for the design team in the process mechanical to accept the information. He's going to the engineering, selecting the cases that he wants to publish based on his design, and taking a snapshot. This snapshot will be available when a process mechanical engineer is working in the master tag registry here, where he is being notified. The notification is being given to him since he's logged in as a process mechanical engineer. And now he's about to review the data and look at the data that was basically passed on and authored by the process simulation engineer. So moving along here, that's what he's doing now. He's looking at the data, and the data can be displayed now to him, and he can choose as to what data he needs to process and bring it into the master tag registry. And in this case, the changes was really focused or the modification or the addition of two exchanger, the exchanger 6 and exchanger 7, with all its properties for the summer and for the winter case in this case. And he's updating now the master tag register with the data. Data has been already authored and saved, and he's setting the case, in this case, the summer case that he wants to run. And from here, what is he doing now? He wants to go through what we refer to it, the intelligent type of information, passing information from the process simulation graphical presentation into the BFD by simply dragging and dropping the information into the BFD, where information is automatically passed on to the BFD for the same type of class, in this case, the exchangers. I'll move it on here. And he's zooming into here. He wants to now, because of the class intelligence that is built into the system and the intelligence of those graphics, it can say, this information match this information. I'm going to go ahead and apply it. And as you can see, it puts the tag automatically. And now my BFD, which is one of the deliverables, are automatic. Information are saved, and information are populated as the engineering master tag. And as a mechanical process engineer now, I want to generate a data sheet for this particular heat exchanger and specify which sheet which case I want to pick the information from, and it already generated the data sheet for me. Now that I have done that, I can also define a set case where I wanted to basically change the overall length of that particular exchanger. In this case, I've changed the 6AB from 3,000 millimeter to 4,000 millimeter, and I am about to basically update the data. And now in the 3D modeling, people are doing the design for the 3D modeling can basically go ahead and pull the information from the master tag registry with the new changes that was done for the length of the heat exchanger, and accept the information where the heat exchangers is automatically updated from really the current length of it to the new current that was changed by the mechanical process, and now they're ending up with the new length, the length that was specified by the process engineer. Furthermore, this information of the location, the new location of that particular exchanger, can be pushed back into the tag registry with the new location of the 3D position of that exchanger. The data is updated. Moreover, the data can be taken back now to the simulation for further analysis as well, due to the change of the length of the exchanger. So that really completes the cycle of giving you the collaboration among the design team on changes that happens. It gets notified by the other team. The discipline team the other 3D discipline team can gather this information and execute it on their design phase. I'll move on now. What this video shows you is really the following as the drive result from being a document-centric, where none of what you saw in the video could have been happening because you have unconnected data trapped still in silos, in Excel spreadsheet, in a static document, non-intelligent, to a single platform, allow access to data in context with minutes, not even minutes, but seconds. You're just notified and you get the information. The data-centric approach that really information passed automatically. You are not prone to error anymore because the information is passed through digitally. And at the same time, you are setting the standardization. It is a standard driven, and also the application really is scalable when it is on a cloud offering, and it is managed and basically by the end user as well, as to the upgrades of software and the upgrades of versions of the software. Finally, really here, what is AVEVA Unified Engineering on Connect addresses the process challenge in engineering, having to have really a functional need. What I mean is the functional needs, along with the functional benefit of the solution regarding the simulation, the engineering, the design, the managing around a one central data repository allows us really to ensure a fully integrated offering to ensure the business and the functional goals are met, and that will really make our financial goals also met, which is really executing projects on time, on budget, with seamless handover for the maximum return on the investment for this type of solution. This is just the last slide for me to tell you about really some of the testimonials of our customers as to what would they have experienced utilizing a system like that. From the simulation, you know, this company has saying that we were able to accomplish 15% reduction in the simulation detail design man hour. On the collaboration with Wood, it says the integrated engineering and design execution, it really enabled us to collaborate better. Into the sustainability, they saw a 3% reduction Eastman from the TIC and 30% reduction in the engineering design cost within a year of implementing the software. And on really the engineering and the design with our Vista project, they saw a 10 to 15% reduction in feed man hours. That's just some of the testimonials. There is a lot more, but I chose those for you to take an idea about. And finally, this is really the end of my representation. I'll open it now. I know we have almost 4 or 5 minutes left over for any questions to be answered. And I'll turn it back to Kyle to really moderate those questions.
Awesome. Thank you, Sam. Yeah, sorry, there's a truck driving outside my house. Hope you guys can't hear that. But all right, yeah, we're opening things up to questions now. As I said, you can drop things in the chat box or use the Q&A. Use the Q&A section here. We actually already have a question ready and waiting. So we got a question. What is the workflow when it comes to implementing unified engineering for existing facilities? Are there any tools that support development of a digital twin based on existing information?
Okay, on existing information. He's talking about maybe a brownfield project. Yes, there is some sort of workflow where we call it data aggregation, where the system can, and specifically the master tag registry part of it, can basically aggregate the data and import them as they go along, if that was to be an existing facilities. There is a workflow for that within our tools to allow you to do that, and you can start it from aggregating and basically processing the import of data into our master tag registry. And from there, data can be either consumed by other users, or data can be also authored with more data as to make it rich in the information that they require. So there is a workflow that can be set in place based on certain scenarios of what is need to be accomplished. As I mentioned in the workflow between the application, and that will be one workflow of processing data from existing facilities.
All right, looks like we got a follow-up from the same person. What about an existing plant SCADA project or just PIDs?
From the PNIDs, okay. PIDs, does it mean SCADA system or PNIDs, process and flow instrumentation diagrams? The question is to the person he is asking. If it is a SCADA, it means it's a real-time data. Is that what he meant?
He says both as separate parts.
Okay, both are separate parts. I'll address the first part, which is the PNID. There is a process from an existing facilities with our system, where because our application, most of the application, and in specifically the PNID talks about we follow the standard of the ISO 15926 or the DXP standard. if that application that they have, the existing facility, does allow extractions of DXP files, AVEVA can consume this DXP format and generate the data and the graphics for the existing facilities information. As to the other one, which is the BID and the SCADA, that's something really more on the operational side, and that could be also not much of it on the engineering side, but we have another portfolio solution where we call it AIM, and of course the BI, which is our OSI soft application that allow that information to flow into either the AIM, which is our asset information management, which is system of records, or the BI solution, which is more of the real-time data historian management.
Awesome. And then we have another question here. Can you change or define the datasheet templates?
Definitely. Datasheet, we supply the system as it comes out of the box with all the BIP standard, if you're familiar with the BIP standard, and that's on the mechanical and the mechanical process. And they are the Excel style like sheet, as you saw in the video. Or for the instrumentation, we supply all the ISA standard. But nevertheless, if you have your own standard and they are Excel format, we can take this Excel format and it becomes the template that you would add to the system after going through a little configuration by mapping the template cells of your Excel file to our database attributes, and you are ready to use those for any instance of generating as many tags for any assets in the plant with those templates to generate the datasheet specification. Yes, the answer, you can do that.
Awesome. And then we have one more from the person who asked the first question that says, so if you have a plant SCADA project, can you import it to Unified Engineering and revise to develop a digital twin?
Well, that's really a vague question to me, because what type of data would you... The answer, yes, you can, but what type of data do you want to really input into the digital engineering, into the engineering design phase? That's really where I'm not sure if they're going to benefit out of it, but if it is really engineering data, yes, you can bring it in.
Looks like they said equipment models and
Yes,
tags and HMI
yeah,
screens.
you can. Just like I mentioned, our engineering, the master tag registry can consume data from multiple data sources. Let it be SCADA, let it be relational database. We can consume this data into our engineering data-centric approach, whether it's equipment, instrument, piping, valves, any industrial asset, any industrial plant asset can be imported into our system. That's the niche, or that's really the flavor and the strength of our tools.
Awesome. Now, I do know we are a little bit over here, but I do want to give anyone the chance if they have any last-minute burning questions. Just another quick second here to see if there's anyone waiting. But we love the questions, you guys. Appreciate all the
They were good
interaction.
questions. Good questions.
All right, we'll leave that open, but for now, I'd like to thank you, Sam, and I'd like to thank you, everyone who attended. If anyone would like to review any portion of this webinar, a recording will be available on our YouTube channel and on our website, california.avevaselect.com. And once available, you will also be receiving a copy of it via email. Awesome. I don't think I see any questions, so I think I'd just like to thank you guys again for attending, and I'd like to wish you all a great day.
Thank you very much as well for taking the time of your busy schedule for attending our webinar, and I appreciate that. Thank you. And thank you, Kyle, for moderating that.
Absolutely. Thank you. It's a great presentation.
Thank you, guys. Thank you, and goodbye for now.
Thank you, Chris. Thank you, Mason. Thank you, Chanel.